Netcasts you love.
From people you trust.
This is Twit.
This is Triangulation, episode 362, recorded Friday, August 24th, 2018, for airing August 31st, 2018. Bill Atkinson, part 2. This is Triangulation, the show where we get together with some of the best, most interesting people in technology, and we just get to set and spell and talk for a spell, and it's so much fun, and this is going to be a fun one. It's part 2 of our conversation with one of the most legendary programmers in Silicon Valley, a person that so inspired people that they came to be around him, a man I've admired from afar for so many years, and we got to know a couple of years ago when he first came to a Triangulation. Bill Atkinson is back, the man who wrote the basic quick draw routines. In fact, about 80% of what was in the Lisa and the Macintosh was coded by his hand. He then started General Magic. We're talking a little bit about that. Wrote HyperCard. Let's not forget HyperCard, which still to this day is really the inspiration for so much of what's happened in software. And Bill is here to talk about. By the way, I want to pause and let you all go watch last week's episode, so we can catch up with what Bill's up to. Really an inspiring person, photographer, so much more. His photocard app is available right now. If you want a little bit of Bill Atkinson, unless you have a Mac, a 128K Mac in your living room, as we do, you might want to go out and get photocard for your iPad or iPhone and use it to print beautiful images of your own or of Bill's. Welcome, Bill. It's great to have you. Part 2 of our conversation.
Thanks, Leo.
So we've completed our visit to Bill and Apple. And when Steve Jobs left Apple, was that a wrenching experience when he was fired? How was that for you?
Well, he wanted me to come to Next with him, and I was in the middle of HyperCard, and I said, I need to finish this.
Yeah.
And he was bad at me. He said, if you were really my friend, you would come to Next. And I said, if you were really my friend, you'd want me to finish this thing I'm working on. It's important.
Yeah.
And so there was a little bit of a time where we didn't talk to each other that much.
I think I remember we talked about this last time you were here. You became friends, or you reconnected later.
Yeah.
Did you visit him as he was dying?
Yeah, I did. I did.
What was that like?
Sad. I remember hugging him, and he was sort of not there. He was so small and frail.
Yeah, yeah.
I was also kind of mad at him that he didn't listen to his doctors and have the damn thing cut out. He thought he could do it different.
Right.
And it didn't work this time.
Yeah, yeah.
Do you think
he could have been saved?
I visited his grave recently. And
did you?
Had a little. I don't know if he was listening, but I had a little conversation. He enabled me at Apple. He believed in me, and 90% of what I was able to do at Apple was because he believed in me. So I owe a lot to him and to Jeff Raskin, who got me there.
Yeah. Jeff was later forced out by Steve because Jeff wanted a toaster. You said an appliance computer.
Jeff
Raskin.
Jeff Raskin is the initiator of the Macintosh project.
Right.
But what he was building wasn't a platform, and Steve Jobs had to take it away from him in order to make it into a platform.
A platform as opposed to a product.
Yeah. When you buy a toaster, it does what it does when you buy it. It's never going to do anything else. Jeff wanted an information appliance. Steve wanted an open platform that people could write new stuff for. Our computers do something new every year.
Yeah.
Shoot, my Tesla is the first car that is a platform. It does something new. I've had it about a year, and when I got it, it didn't have the map display on the left behind the instrument cluster. It keeps doing new functionality.
Because it's a platform.
In fact, I drove it up here today, and 90% of the time it was doing the driving, and I was just sort of keeping my hand on the wheel and babysitting.
Be careful. Keep that hand on the wheel. We don't want anything to happen.
Yeah. But that's really why Steve had to take the Mac project away from Jeff Raskin, and he was right to do it.
Steve seems to have very good instincts when it came to these things. I mean, he knew. Did you thank him when you visited his grave?
I certainly did.
Yeah.
Yeah.
Yeah. It's good to have gratitude. So you finished HyperCard. Jobs is gone. Scully's running the place.
And Mark Peratt came to me and showed me a project he was sort of researchy project that he was hired into Advanced Technologies Group to find out what was next after the personal computer. And he had this project he called Pocket Crystal, or sometimes he called it Paradigm, because it would be a paradigm shift. And it was for something small in your pocket that was with you all the time and that accessed information and communicated. And Apple made computers. They didn't want to have anything to do with consumer electronics back then.
Right.
This was 1990.
Right.
So in 1990, I left Apple with Mark Peratt, and I convinced Andy Hertzfeld to join me. I said, "Hey, this is really cool. What he wants to do is groundbreaking. It's much more interesting than just working on computers. It's a shame that Apple doesn't want to do it, but we should do it."
Yeah.
And so I wrote this vision statement as we spun out of Apple to form General Magic. So the three of us co-founded General Magic. And what I wrote back in 1990 was, "We have a dream of improving the lives of many millions of people by means of small, intimate life support systems that people carry with them everywhere. These systems will help people organize their lives, communicate with other people, and access information of all kinds. They will be very simple to use and come in a wide range of models to fit every budget, need, and taste. They will change the way people live and communicate. We're assembling at General Magic a world-class team of hardware, software, and user interface designers to explore and invent these life support systems and to constantly evolve and improve those inventions." So we had this vision, and I'll have to say Mark Peratt had the vision, and I subscribed to it, and I said, "He's right. This is the thing we should be working on." And I dragged Andy into it too. And we formed General Magic to invent the personal communicator.
By the way, I noticed that's written in New York printed on an image writer. So is this the original?
This is the original, but it's not on an image writer. This is actually printed on a laser printer.
Okay.
We had a laser printer back then, but this was printed in 1990.
Wow, that's it. Why did you write that?
28 years ago.
Who did you write that for?
To explain why we were spinning out.
Right.
Why...
It was a spin out too. John Scully wrote a check. It wasn't.
Yes.
It wasn't you split off. It was really something that Apple
was a big partner with us.
Yeah.
And we went out with John's blessing, and he was one of our biggest supporters. He said, we don't have the wherewithal to do personal electronics.
Right.
We do computers.
Right.
Later, the Newton was sort of a little,
only 4 years later they did personal electronics.
Yeah.
So I happen to have one in my pocket, actually. It really did change my life. I carry this with me everywhere. This is yours. This is the Magic Link. This is what came out. Now, this isn't what you would hope to make, though.
Well, what we hope to make would be...
You have something else.
Let me find my little...
This is what I wanted.
Mark had made some beautiful models, and this is one.
He had a giant red notebook too with sketches, and I mean, he had spent a lot of time thinking about this.
His drawings looked a lot more like an iPhone than what we ended up
rounded
making.
Corners and all.
But here's one, and
this is great. Let me show this.
So this is
that's a cassette
sort of
box.
a mock-up. It's 8mm video cassette. You remember that format?
Yeah.
They don't even make that anymore.
But you have in here an insert that shows a desktop. It's what today the kids would call skeuomorphic, because you have a clock that looks like a clock, a phone that looks like a phone, a Rolodex.
Yeah, we wanted to take the desktop interface.
Let's turn on the actual. We have a working Magic Link here. This was the only one ever made. It was made by Sony in conjunction.
No, Motorola made this. Motorola Envoy, which was the first wireless one. This one didn't even have a radio in it, so you had to plug it into a telephone jack to actually send and receive the cards.
And even though this is the early days of the internet era, it wasn't on the internet. There
was no web.
Yeah.
There was no
90s.
web. There were no web browsers. This was 1990. This
Right.
came out in 94. Mosaic came out in 93.
Right.
And you could count the number of websites on three pieces of paper.
Yeah. So this was a proprietary network. AT&T was a partner company.
The user interface started with a desk, sort of like we have the desktop on the computer, right? And
did you when you are designing this, you're thinking we want to make this friendly, we want to make this something people understand? Was that the reason?
Of course.
Yeah.
If something's not understandable, it's useless.
Right. Did you think it was important to have a calendar that looked like a calendar and a Rolodex that looked like a Rolodex, or? Because we've gotten away from that now, right?
Well, that's a long time later that Apple dumped skeuomorphic.
Right.
And I'm not sure that they did a very good job. I actually think that the old things actually worked pretty well. Here's a desk.
Yeah.
And
with drawers and everything.
One of the concepts that we had was telecards, a little electronic postcard. Now remember, this is before text messages.
Right.
So take a picture, flip it over, write a little something on the back, and send it off into the ether.
Photocard.
And I got, well, the photocard has some ancestry there. And your daughter says, oh, I got a telecard from Dad.
Can you show us? Let's do a
to make a telecard.
Where are you going to get the picture from?
You touch on the, well, this one doesn't have a camera in it. So
but some did later?
There were camera attachments in the models.
Okay.
And the Philips one did.
And you had a...
Here, I'll make one to Leo Laporte.
Card index. I'm flattered that I'm in there.
In this 28-year-old model. This is 24 years. So 20.
I think that's a little retroactive editing of the content.
You can write on it.
Oh, look at that. Now, you didn't attempt...
You can also type.
You didn't attempt handwriting recognition, though.
No, we thought that was a fool's errand, and we were right.
Yeah.
The Newton proved it.
That's what killed the Newton.
But but you could bring up a keyboard, and you could type, you know. And if I switch to caps, the keys go to caps.
Something that the iPhone didn't figure out
for a while. Or you switch to numeric, all the keycaps change.
Fancy.
You can type with a projected keyboard. You can use your fingers.
So it's a touch screen, but it's a resistance.
One of the old kinds of touch screens. They're made with 2 sheets of resistive material and a lot of little teeny glass beads in between. And when you press on it, it's kind of shorting out the 2 sheets.
It senses the pressure.
And so it's sensing, well, put a voltage gradient across one and a voltage gradient across the other. You can tell the X and Y coordinates by when they touch.
Cool.
Okay.
Cool.
So you can write on it, you can type on it.
There's some great video in the documentary, which everybody should get a chance. I hope gets a chance to see.
And you can add some stickers to it.
Of Megan Smith showing all the prototypes for the digitizer. How hard that was. Oh, look at these.
Here's a sticker with my signature, or here's let's get.
This is very much like photocard, Bill.
Here's some animated stickers. Let's choose here a rabbit here. And the rabbit moves, it's animated, and when I drop it, or if I touch it,
his ears move. Oh!
And if you get one of these cards, it can animate, or you could put on a sticker. Oops, wrong thing.
It's hard for somebody today to imagine how unusual and different this was in 1994. This was, as you said, the web was...
This is before texting.
Yeah.
Let alone before the internet and before digital cellular. So let's put on a voice note and tap on it and record. Hi, Leo. It's great to be with you.
Hi, Leo. It's great to be with you.
That's awesome.
So you get this card, and it can have, here, let's put this away. And it can have voice on it. It can have animations. Here, I like the little animated walking.
Yeah, they showed that in the and
it's walking across.
Isn't that cute?
Right, and then you can send it. Now, so one part of it is sending messages like this that we would call it we call it a telecard for an electronic postcard.
Right.
If I go back to the desk here, you can look at my inbox here. And this one actually has one that Laura sent when she was 8 or 9 years old. and it's got a voice note. Now, this was beamed to me. It says it was beamed. There's a infrared, so you can beam it from one to another.
Oh, look at that.
And Laura was 8 or 9, and she's 33 now.
It's so... Now, did you know when you fired this up that was going to be on there?
No, I didn't. In fact, this is actually Sue's
That's amazing.
Magic Link. And
That's amazing.
I was really pleased to run into
I
that.
bet you were.
I ran into that last night.
So you haven't heard this in years, 20 years.
Yeah. And here's
24
something,
years.
a little piece that I put on it.
Kentucky Fried Chicken.
Okay, so
Wow.
user interface-wise, we have the desk here, and it's got a phone on it. You can make phone calls, look somebody up, and call them, right?
So you could actually do a real phone call on this.
Yeah, it has a phone jack on it. And
Oh, okay.
it's
You
a
have to
phone,
connect
right?
to that. You got to remember,
and
this
here's
is not wireless. This
No, I
is,
do. Well, Motorola's was wireless.
Okay, the Envoy was.
Okay.
Yeah.
And here's an address book with cards in it, and here's a notepad. You can type or write on it, or put animations on it.
What's the magic lantern do?
This one is commands. It's supposed to be a genie lamp,
Ah.
you know. And so you can say, I want to find something, I want to file,
Got it.
print,
Got it.
revert, or do spell checking. I want to contact somebody, do mail or fax, or beam this to somebody. I want
This
to beam this
predates
card to another.
not only the Newton, but the Palm Pilot.
Oh, yeah.
Oh, this is the
Yeah.
first one of these.
Yeah. And then the
How much of this was already in the Red Book that Mark Porat did, and how much of it came later?
concepts were in
He had the
Mark's book,
idea.
the implementations and the actual features, and like the icons are all Susan Kerr.
The great
like
Susan
this is
Kerr
a little
did the
valise.
original
You
Mac
can
icons.
you can carry things from one place to another instead of copy and paste, where it kind of disappears from view and
Yeah.
it's kind of theoretical, and then
Yeah.
you paste it. We let you drag and drop it into the valise, and then drag and drop it out again someplace else, so it didn't get lost. This is kind of what we would call the clipboard,
Right.
right?
Right.
We have a little trash, and because the trash can is vertical, we made this a trash truck. So you want to throw out something. So you want to throw out something here, like this.
drag it to the
I don't
truck?
want this. You drag it to the truck,
Oh, look at that.
and it goes into the truck. Or you can open it up and pull something out, or empty the trash.
Yeah, don't throw out anything important.
Empty the trash there.
That's just the message to me,
Okay.
I hope. Yeah.
Now, here's our inbox, our outbox, our filing cabinet. So you can file things away and have different folders to put things into, but keep it kind of physical looking.
Is there an operating system underneath this?
The operating system is called Magic Cap.
It's the Magic Cap operating system that the Magic
Or here's a
Cap runs
clock, calendar.
on. Are these
clock
apps,
calendar.
or is this all part of the operating system?
These are built-in apps. These are part of the operating system, but you can get apps too.
You could
It was an
get
app
apps.
store.
Okay.
So we start with the desk, but what would happen if you zoom out from the desk? So you can go out to the hallway, where the desk is one of the
Wow.
doors in a hallway.
Wow, look at this.
And you can travel. Here's the library, and it has teaching books, getting started and basics in writing and various. Here's secrets. I like that one. How do I do this trip? And the book you're working on, it kind of sets aside there. You can read through it, and you can put that away, and you can put it back up on the shelf.
So it's interesting. You do have zoom animations. There's some animation. You don't have a page turn animation. There's some things you probably didn't want to spend too
Now
much.
we're in the hallway here.
What's the processor in this?
It's an ARM processor. Not a lot of power.
Okay.
But low battery drain.
Right. This must have been one of the early ARM processors. At that time,
Here's,
Apple was a partner with ARM.
Here's controls. This is what we would call settings in Mac.
Yeah.
And you can set things like I want to set the screen properties, for example, to calibrate the screen. You can say adjust, and you would touch there
I love the
There.
animations. Wow.
and there, and you've calibrated the
Right.
screen. Or things like the volume, or like within general, there are things like the battery level, what to show at the top, and things
Right.
like that.
Right.
Now, you walk down the hallway, And there are more things. Oh, here's a game
Picasso.
room. Right. That's a Susan Kerr Picasso. And here's a game room. So you could go and add games to it. You could go, there was an app store, and you could add, so here's like this is a little...
It's Othello, right?
Othello game.
Yeah.
And you could go and play Othello. And you could buy new games for it, add it to it. You could go to... here, let's go back to the hallway. There was a solitaire game, and there's this word game that we all played. We loved. It's just a bunch of letters, and you try to make words out of it, like S-T-A-R is the word. S-T-A-R. Well, I'm not sure why that's not working, but that should make a word. Maybe the process is being a little slow. Now, let's go down the hallway a little more.
Was it pretty reliable? Was it pretty robust?
Yeah, it didn't crash that much. Here's Rogue's gallery. This is
the guys that did
it. If you look at these names, a lot of these names, these are people who made it big in Silicon Valley afterwards. Tony Fadell, who did the iPod and the iPhone.
John Giandrea, who is now
head of AI at Apple.
Yeah, back to Apple. Andy Rubin.
Andy Rubin is Mr. Android.
Yeah.
Anyway, a lot of people went into making this.
The story of Tony Fadell getting this job. Do you remember Tony as a kid coming to you and saying, "Please hire me, Bill, please"?
So we're at a hallway.
Yeah.
Everything in the hallway is on this device.
Yeah.
Right? We had a desk.
Right.
And you back out, you're at a hallway.
Right.
But now what if you want to go outside of this device?
We can do that.
So we go to downtown. And downtown has a street.
Oh, wow.
And buildings on it. So you can go to the AT&T store, or you can go to the AOL store. This is kind of the first... Remember, there's no web.
Right.
There's no internet yet. But this is where you would go and buy some apps. I'm going to buy some apps for this thing, or I'm going to subscribe to a service for this thing. This notion kind of you've got the desk and the hallway and downtown gives you kind of a scoping of this, and you can always get back to the desk by touching on desk.
Right.
That's your kind of home base.
Never get lost.
No matter where you are, touch that and you're back at home.
Yeah.
But you can get out into the world all the way out into downtown.
Right.
And obviously that could be extended to bigger than one street. Now you could be going out into the world. But remember, the internet wasn't there.
Right.
There was no World Wide Web when we made this thing. So this is a Magic Link from Sony. It isn't as small as we wanted it. It isn't as cheap as we wanted it. We wanted these to be $50 a piece because when you buy a set of walkie-talkies, you always buy at least two.
Yeah, yeah.
Right? We wanted each member of a family to have one so they can send cards to each other.
Was that unrealistic to make that $50?
It wasn't possible at that time.
Even today, it might not be possible.
And this isn't a backlit display, and it isn't color, and the processor isn't zippy fast, and the whole thing is too lunky. This isn't pocketable. This could be put in some bulky purses, but it's not pocketable. It's sort of size of a paperback or something.
But you're stuck with the technologies that are out there. And how much did this end up costing?
I think $890 or something like that.
And that
Initially,
was the biggest problem.
I think it went down to $300, but
by then it was too late.
Yeah.
Yeah.
Just the bill of materials was such that it couldn't be sold for a cheaper amount. Cell phones, when they first came out, they hid the cost.
Right.
You got a 2-year contract, and they don't let you know how much of that is going into the device.
Yeah. We know now it's a lot.
Well,
it's the same price as that.
You know what they used to do on cell phones that was really pretty sneaky? They would charge you a certain amount per month, sort of amortized. You take 1/24 of the price of this thing and charge you that per month.
Right.
But 24 months later, your rate would not go down.
Yes, you don't
they
own
would.
the
It's
fund.
like you paid off the mortgage on your house, but you're still paying
You're still
every
paying
month
forever.
Right.
And then after they stopped the subsidies, they continued to charge the monthly fee.
Yeah.
They're no fools. Yeah.
So this is the Sony Magic Link. There was a Motorola Envoy, Matsushita, Philips, Panasonic. We're all working on them.
Mark put together some amazing partnerships. I mean, you had some really big companies involved.
Well, it was very important that they be interoperable. We had the experience with Betamax and VHS cassette tape, video cassettes. And the people who bought Betamax really got screwed because you went to the rental store and all they had was VHS tapes. So we wanted these to be interoperable in much the same way that audio CDs are interoperable. It doesn't matter whether you bought your player from Toshiba and your, the CD from Tower. So we wanted them to be interoperable and all be able to send and receive telecards to each other. So we made a reference platform and a test suite that all of our developers that we worked with had to pass. So we would kind of certify them as Magic App certified. There was another aspect to this that the video didn't really cover, which is Telescript. Telescript was a big part of what General Magic was doing, and the video couldn't really take the time to explain it.
So this is what Sue was working on.
Yeah.
Tell us about that.
And a good third of the company was working on Telescript. This was a way to make an agent, an intelligent agent, that you could launch out into the world to do your bidding, and it would run on other platforms and report back to you. For example, send it out looking for a good deal on a flight to Hawaii, and it would go a bunch of different places and come back. So it's the opposite of a search engine. The search engine now, we have sort of that functionality, but this was actually my code running out there. Or I could write a little thing that would say, watch my checking account, and if it gets below a certain amount, let me know.
So
and that would run on the bank's computer.
Tell me about this architecture, because that's an interesting...
Yes.
There's nothing doing that.
It's agent-based programming, and it was way ahead of its time. It was never accepted. Nobody does it today.
Yeah.
They do the opposite, which is little bits of JavaScript can be downloaded to my web browser and executed on my Mac. But the opposite of my code being run on the bank's computer or on a travel agent's computer, that's not done now.
I remember people talking about this notion of agents going out and doing your bidding, and I didn't realize that we'd come that close. What was the architecture? How did that code get transmitted? How did it get run? Did you have to have an interpreter and all the participating?
There were Telescript interpreters, and they could run on the infrastructure of, say, the bank's infrastructure.
So the bank would have to dedicate some portion of CPU to an interpreter, basically. And it would be getting, and it would have to have an input.
They would install a Telescript interpreter, and when it got a Telescript thing, it would give it to that to execute.
Here, you handle it.
And it was very carefully architected. One of the biggest issues or problems you might have there is viruses.
Yeah, of course. Yeah.
And so it was very carefully designed so that it can't do anything damaging.
Yeah.
It can't delete files, and it can't steal information that it shouldn't have access to, and things like that.
Could users write their own Telescript? How would a Telescript get generated?
Well, for example, you would use a form on this thing, and it would send out the Telescript for you, so you wouldn't have to actually program it.
So it's kind of like Automator or AppleScript in a very early fashion. Was the HyperCard language part of this?
No, not at all.
Not at all.
Not related.
Not at all. Yeah.
No, HyperCard, the HyperTalk language. Was an event-based programming.
Much like AppleScript later was. Yeah.
Well, AppleScript was based on HyperTalk.
It's basically HyperTalk.
It was make it system-wide so that you can use Photoshop as a subroutine to your AppleScript. Right. But no, HyperTalk was really an easy introduction to event-based programming. Most non-programmer people don't think in terms of if then else. They think of action reaction.
Right.
You poke here, it does this.
Right.
And in fact, if you have two buttons, yes and no,
that's really what happens.
Poke here, it does something. Poke there, it really is an if poke on yes,
Right.
else if poke on no,
Right.
else if poke on maybe.
Right.
You know, but if you think of it in terms of event-based, that's really what HyperTalk was about.
Right. So tell me more about Telescript. I find this fascinating. You're right; they didn't cover it in the movie at all.
Well, they couldn't explain it in
It's too techy, I think. Yeah, too technical.
I think Telescript was one of the breakthrough innovations that General Magic had that hasn't caught on.
Could you architect something like that today? You'd have to.
Could I?
So how about one? Could one?
No, it takes a whole movement.
You need a consortium. A lot of people. Who agree to do it.
You need the travel agent to want to run a Telescript interpreter.
Right.
Right. For example, there's good reason why web browsers run JavaScript.
Right.
Because there are a lot of websites that dish out some
code
JavaScript
on you. Yeah.
But those, that took a JavaScript consortium.
Right.
To get the web browser guys to say, okay, we'll execute JavaScript.
Mark was pretty impressive in his ability to put together all these partners. So was it Mark that did most of it?
Yes, he was really the business guy. And one of the problems is getting these big guys who are competitors to each other.
Yeah, Sony and
to
Panasonic
play
don't love each
together,
other. Yeah.
And also avoid issues of price fixing and kind of
they can't.
They have to avoid monopoly issues, antitrust issues, and all that.
They're not allowed to collude.
They were only allowed to know a certain amount about what each other was doing. They had to know some in order to place themselves in the right place in the market, but they couldn't do price fixing and say, oh, well, I'm going to sell mine for this, and the other guy says, oh, well, then I'll sell mine for that.
After this, Mark Porat left technology entirely. He did startups
well, he
in
needed
real
a break.
estate.
He needed a break because
do you think he was broken by it?
He well, at first.
Yeah.
He bounced back. He had two tech startups after that, clean energy startups.
Right. That's his thing now.
Like Solar City and what's the other one? Anyway, he's not broken now, but he had a lot of pain over it. Yeah. He had convinced these big partners to go all in with him. We had a $96 million IPO.
Yeah.
And the $96 million got lost.
Yeah.
And we had people who bought General Magic stock that once it went public that lost their money. And we had, and from a technical point, we had a lot of engineers who bet their life on this and bet their time and energy. And this is where I felt that I had failed them, as I lured Megan Smith and Andy, I lured a lot of my friends to come work on this cool project. Let's go make this telecard transceiver.
Right.
And we failed.
I think there were, the sense I got, I think maybe it was from the movie, was that people like you and Andy were looking for the next big thing, that you'd done something so important with Macintosh that you needed something of equal importance for your next project.
Well,
is that true?
That wasn't why we did it. We did it because it was
exciting.
We wanted it to happen.
Yeah.
You could say, Steve Jobs said, drop your nets, come and follow me, I'll make you fishers of men.
Right.
And we were looking for the second coming of Jesus Jobs.
That's right. Yeah.
And Mark wasn't Jesus Jobs.
No.
But this idea was an idea that had a lot of resonance. And it's eventually, I would say, some of the press is saying, oh, well, we invented the iPhone. We had a lot of ideas that eventually got implemented in the iPhone.
Well,
I've got this thing in my pocket that
it's a lot closer to that cassette than it is,
and it's closer to my description of what we were going to build.
That's what really struck me when you read that proposal. You're really describing the ecosystem, not just of the iPhone, but of the smartphone. You're really describing the revolution of the smartphone.
Yeah.
You didn't have. There was a piece missing. You didn't have that global internet communications.
Oh, we didn't
network.
even have digital cellular.
You didn't have wireless.
There was no digital cellular.
Yeah. So this was really way ahead of its time.
Went over this ancient Artist system that was 1,200 baud.
Yeah.
really slow and kind of expensive.
It was also the parts were expensive. It was hard to make this at any reasonable cost.
I'm going to...
Had you had more time and more money, could you have eventually reached the iPhone or something like it?
It's really a matter that the industry had to mature, right?
Yeah.
General Magic could not make digital cellular infrastructure.
Right.
Right? That had to be there, right?
Yeah.
Well, I mean, but the whole world had to be full of digital cellular devices, right? General Magic couldn't make an inexpensive capacitive type sensing that would allow you a gentle stroke instead of a push, right? Couldn't make a big, bright, beautiful color display. That's not something General Magic could do. We had to wait for the industry to move along.
Catch up.
General Magic couldn't miniaturize the things so much that we could fit. This is more powerful than a Cray 1.
Yeah, a supercomputer.
And we have a supercomputer in our pocket, and we have a beautiful camera in it.
Yeah.
I'm a photographer. I use photographs all the time.
Yeah.
And when I travel to Bhutan, this is all I take with me. I don't need to bring another camera. I get beautiful photographs by the thing that's in my pocket. And, you know, Sony might have been able to come up with a camera for this, but over time, it just takes time. Remember, this thing was shipped 24 years ago.
Right. Actually, in a way, if you think about it, that's not very long ago. We've actually made huge leaps in 24 years in what's been possible. I want to take a little break. We're talking to Bill Atkinson. He created the quick draw routines for the Lisa. He created Mac Paint for the Macintosh. He created HyperCard for the Macintosh. He created the Magic Link photocard. He's a great photographer and a great thinker, and it's a real pleasure.
I didn't create the Magic Link. I was one of a team.
One of many.
Well, I did write quick draw and Mac Paint and HyperCard. Well, HyperCard, I had help with Dan Winkler on the language interpreter, but the rest of it, I wrote all the code. I was on a team.
That has changed, right? You couldn't, nowadays, no single person could create something like that.
Steve Jobs once said, it takes one person to paint a portrait. 100 people can't paint a portrait. They can paint a fence, but they can't paint a portrait. If you want to have something to have an integrity, it has to have a single mind. But the tasks we have today are so big that they can't be done by one person.
Right.
So that's where the job of the visionary is to erect a clear vision and hold that vision and get all the different people to sign up for that vision and work on that vision, so they work together like left hand and right hand of a portrait painter. They can work together. But a single mind of what we're building is what creates integrity.
And
that's what he did better than anything else is help to hold the vision up.
He was so good at that. He was able to
if somebody were applying to work on the Mac team, he'd spin the vision, and if they didn't sign up for that the way it was,
that's how
they should work on something else.
Yeah, that makes sense. Do you miss writing code?
Not really.
No.
No.
It was always a tool for you, wasn't it?
I'm surprised I don't miss my nature photography either.
Yeah.
Like, I've moved on. I'm doing something else now.
Yeah.
You know, I became a world expert on color management, and I don't miss that at all. I did it. I made some enhancement. I taught 400 photographers how to get prints that matched their images, but I move on. And right now what I'm working on is consciousness.
You're like the original Apple logo with Sir Isaac Newton, a mind forever voyaging.
I'd just say I work on something until I'm an expert at it, and then I want to do something else.
That makes sense.
Right? You get bored once you're, you know, if you're not learning, you're, you know, starting to die.
Yeah. So last episode, we talked a little bit about your what you're working on today. Let's talk a little bit about that consciousness. Back to your roots as a neuroscientist. If you saw the episode, you know that Bill was working towards a doctorate in is it right to say neuroscience?
Yeah.
And abandoned it to come to Apple.
Yep.
Now 40 years later, you're back.
40 years ago, we didn't have the kind of tools we do now to research minds.
What are the tools that are...
They were looking at things like, you know, evoke potentials and, looking at individual neuron responses. We're looking kind of at the micro level. They didn't have the kind of tools that we have now. One is functional magnetic imaging, functional fMRI, where you can look at the functioning of a brain while it's active, while a human brain is doing something.
It's much more holistic instead of, just
give
getting
them a task.
Yeah.
Count down backwards from 1 to 100. Now do it without moving your mouth.
Yeah.
What's different?
Yeah.
Other tools that we have are, there's a new technique that allows us to map out the major pathways in the brain. Water molecules are always jiggling around, and this new technique allows you to measure what's the average direction of the water molecule jiggling. And when they're in a confined space like an axon, will they jiggle more along the longitude of the axon than transverse to it? So you can now map out the major bundles of pathways and get kind of the wiring diagram of the brain. Maybe that sounds
Brill has
theoretical.
some great show and tell stuff. We got boxes of show and tell.
I'll bring up a picture of it. So the Human Connectome Project.
Is this your primary computer now? Is it a 12-inch iPad?
I have a 27-inch Mac that I use.
You'll still sit down
iMac,
at that? Okay.
5K.
Yeah.
But I use this probably more than that.
Interesting. Yeah.
I will not buy another laptop until it has a touch sensor on it.
Yeah, I'm with you on that. Yeah,
I've become so addicted to.
I touch my laptop all the time, and there's lots of big fingerprints on my screen.
I'm going to bring up some images about brain imaging.
So,
we can look at things like this now.
Wow, isn't that beautiful?
We get a picture of the connections in the brain. Now, I did something back in 1974. I did a film. Let me see, 74, yeah.
Where is this coming from? What are we looking at here?
A human brain, a live human brain.
Is this an fMRI?
No, this is this technique where you're looking at which way are the water molecules jiggling.
Oh, this is what you were just talking about.
And you can actually see. So these, what looks like a fiber here is not a neuron. Neurons are really small.
Right.
These are within one, say, 1/10 of a cubic millimeter. Which way are the water molecules moving, and then color code it by which direction they're moving.
And what does that tell you?
Well, it tells you who's connected to whom. So you're looking at this, you look at these radiant, well, think of it like if you were to try and understand how does a car work. Well, an old-fashioned car that had wires. Right now we use computers, but
we have no idea.
Now we have computers that talk on a bus, but the wiring diagram of a car would tell you a lot.
Sure.
You'd see how the brake was connected to, So these
it still feels, as beautiful as these are, that we are using primitive tools to understand something, surpassingly complex. Do we really? Are we getting close to understanding how the brain works?
We understand a lot more about how the brain works than we used to.
Yeah.
First, neocortex is much simpler than we thought.
Oh, really?
Neocortex is where the bulk of what we would call higher level intelligence resides. There are things we learn during our life: math, physics, history, poetry. All of those things are things that we learn from experiences in life. And if you look at the cortex, the human neocortex is a sheet of tissue. And humans, it's about that big, and it's crumpled up to fit in there. A chimp, it's about that big.
Right. And
everywhere where you look, there's the same 6-layer laminar structure. If you cut across it and stain and cut across the cortex, the same six layers are there. Now, that's a little bit oversimplification because the olfactory cortex is old and only has 5 layers. But let's set that one aside. The 6-layer cortex is pretty much repurposable. Any area can be used for any function. The cortex, primary visual cortex, could be repurposed in a blind person, could be repurposed for additional acoustic processing. They could tap a cane and tell you there are 17 steps coming because they have more auditory acuity because they got more neurons assigned to that task. Well, how does that work? How does the learning work? Within these, spanning these 6 layers are cortical columns. The cortical column in a human, it's about 10,000 neurons. In a rat, or about 60,000 in a human, maybe 10,000 in a rat. Within that cortical column, there are a lot of connections, but not to adjacent cortical columns. Humans only have about 1.5 million cortical columns. A cortical column is the basic module of learning in the cortex. And it learns patterns of simultaneous firing, what neurons are firing at the same time, and then temporal sequences of those. Imagine you had a Christmas tree with a whole lot of blinkers, and people in a party room are looking at this Christmas tree, and a kid in the next room has access to the plugs. And he unplugs string A, plugs it, takes it out and puts it back in. And even though they're all blinking, because these all come and go together, the people in a room know without being told that there's common causality. They don't understand about strings, they don't understand about kids, they don't know about electricity, they just know common causality. But if the kid does A, and then B, and then C, and waits a while and does A and B and C, 4 or 5 cycles into this, the people in the room see A go and they say, I bet B and C are about to happen. So the cortical column predicts, it recognizes sequences of patterns and makes a prediction. I think we're in sequence ABC.
Are the patterns sense patterns?
They're whatever input comes in.
Okay.
So in primary visual cortex, they could be straight from the retina, which isn't a bitmap like our digital cameras, but it's already at the retina. It's already processed into little center surrounds and diagonal line detectors and things like that, and movement detectors, but they're really low level. The output of V1, primary visual cortex, loops around, white matter wires go to V2. And now the output of that is going to be a higher level, a much more slower changing output. It's like in our party, there's another floor in the high rise, and a party going on in the stairs above. One of the bulbs in that is the output of this tree. This bulb says, I think we're in sequence ABC. But there are other bulbs from other trees, and they're all coming together. So what happens in V4, where we have a face detector? We're really detecting sequences of patterns, of sequences of patterns, of sequences of patterns, of sequences of patterns.
It's a massively, not that massive, but it's a parallel system.
It's a hierarchical system.
Hierarchical.
And
okay.
because it's hierarchical, you can achieve an arbitrary depth of complexity.
Ah.
Right? It is sequence of patterns raised to the nth power, where n is the number of levels of hierarchy.
Not the number of layers, but the number of levels.
Not the number of the layers within the 6-layer laminar structure, but the number of levels of hierarchy.
So it could be.
So we can now, and
arbitrarily
as
complex.
a recognition part, it recognizes sequence of patterns. As a prediction part, the same cortical column takes a general prediction, like I think we're in sequence ABC,
right,
and a live input, like we're currently looking at a B,
right,
and makes a more specific prediction. I bet C is next, because if we're in ABC then, and we're looking at a B, then C is next. So cortical columns can be wired up to make recognitions and predictions and build basically a model of the world that allows us to predict what's going to happen next.
For survival purposes.
Well, so now what's happening in AI? You can make a piece of software that simulates a cortical column.
Jeff Hawkins wanted to do this, right?
Yes.
At Numenta.
In fact, this is all coming from Jeff Hawkins' work. Okay.
Yeah. We had him on the show, and his book on intelligence is a very good description
The right way
of this.
to make a intelligent AI is to look at what neocortex does.
You think to
model
model it after the human brain?
Yeah, look at what neocortex does works. We know that gives general intelligence.
Yeah.
Start by implementing that.
Right.
And it isn't that hard to implement. So once you have a model of a cortical column, then you set out a network of nodes where each node is running a copy of the cortical column simulation. And you have a non-biological cortex. Now,
why haven't we done this yet?
we have. Numenta's done it, and their platform is...
It works?
Yes. I've made some little test programs myself with it when I was working with them. I made one. I made one that did languages. So I'd feed in paragraphs of text, and then I'd tell them, okay, I got these from Gutenberg project, all these digitized books. Here's this paragraph is Finnish, and this paragraph is Russian, and this paragraph is English. Now give it an unknown paragraph, and it would always get it correct about what language it is. But then I said, well, maybe, and the way you do it, you train it by feeding it in at the low level, the paragraph and the correct answer at the top. And they will come to a consensus. You let it make the
well,
you make it come to a consensus then.
Right.
Because this prediction, it needs to be commensurate with that input.
Right.
And so something will happen in between.
That's machine learning.
Yes. Now, when you trained it on half the data, then you give it the other half of the data where you know the answer, but you don't tell it.
Right.
And see if it gets it right.
Right.
But then I made another one that was all English, but just different authors. So, first of all, the language one, it did better than Sue and I could do when we took the same paragraphs and tried to rank them. But when we did with authors where it's all English, there's a difference between Shakespeare and Ibsen and Mark Twain. It could do that very well too, and it could do it better than we could.
And you're not giving it rules. You're just giving it
just
the
data.
Cause and the effect, and you figure out.
That's how humans work.
Yeah.
Right?
We don't get rules. We just get data.
Yeah. So one aspect.
So this is an effective technique because we talked to Jeff when he was beginning this process, and it's been kind of quiet since. And I was just wondering. So they're already using this.
Yes.
You think this is the path to general artificial intelligence?
I do, because the human brain has been evolved over a lot of time. It's found something that works. That when mass replicated. Right, this cortical column, let's just make a few million of them, and we got a human-level intelligence. Now,
is this similar to neural networks?
Well, neural networks, the early neural networks didn't get it about sequence at all. They were just like billion input NAND gates, right? They didn't understand about both sequence in recognition and unrolling of sequence in playback. So think of it as, like in programming, you say, higher-level task, do this. And then what I mean by that is this and this and this. And what I mean by this is this and this and this. Yeah. You're sort of dividing a big task down into smaller things. This is like the motor side of our actions. Or we have an intention. I'm hungry. I want to go to the fridge. Well, first I have to stand up. Well, what do I have to do to stand up?
Right.
And we take a general idea and break it down to smaller and smaller ideas.
If we had to do it consciously, we'd never get any food.
Well. Okay.
Fortunately.
Even that is an interesting phenomenon because we're not a single eye. We have a plethora of processes running inside us that are running unconsciously, but I mean, you have one right now that's regulating your pupil dilation depending on the illumination.
Right.
And if the lights suddenly change, it'll react.
Right.
But as long as they're changing slowly, you won't even notice that it's doing its job. And really, that's the job of these models, to recognize and predict what's going to happen next so that we can ignore things that are as expected.
Right.
I can reach in my pocket and pull out my keys and keep talking. But if I were to reach into my pocket and find wet Jell-O, I might break my conversation.
That's right.
Because
I certainly would.
Right. So
this is I've been fascinated by this for some time. In fact, since we talked to Jeff. But I didn't
one of the
realize you were
issues that's
making
going to
such
come
progress.
up is really how to teach artificial intelligence's values.
Yeah, are you worried about that at all?
Yes.
Many people are.
What I'm most worried about is not about AI so much, it's about how people are going to use AI.
Right.
We have unintended consequences. Okay, we thought, Facebook, wouldn't that be a lovely way for people to share with each other? Right? And now we have election interference, and we have bodies of people who seem to be hating each other because they're more and more polarized. Somebody's gone in there and chosen to use that medium in a bad way. I used to think when I was doing HyperCard that what the world needed was wisdom. I think now what we need is compassion and empathy, and maybe some kind of spirituality. We need to be thinking at the bigger picture of who we are in the universe and how we belong in an ecosystem, not this, humans plundering nature. It doesn't work.
Yeah.
There's something wrong with this picture. And I don't think it's just about wisdom. I think, anyway, I was getting off on, what I was saying is that you can have a beautiful new technology and it can be used in ways that no one could have anticipated.
Almost always is.
And, you know, if somebody were to ask me, let's say it was back in the time of the Manhattan Project, and somebody were to ask me to work on the Manhattan Project and help learn how to split the atom. And if I knew that the Germans were about to do it, and I might have been convinced to help with that. If I know what I know today, that generally atomic energy has not been such a good deal for the planet. I credit it to most of the cancer that's going on. I would have to say no.
Yeah.
And so I have my qualms about working on artificial intelligence. And it's not because AI is bad. It's because of how some people will use AI. I think we need people to be directed toward doing something good and useful in the world rather than just making money. Right. We have rampant greed and corporations who feel like their whole job is to make money for their shareholders instead of doing something useful and good.
They're basically unintelligent engines designed with one purpose. They're like the paperclip machine.
Well, they're like a virus. They're like a virus.
Like a virus.
The virus that gives you, the virus that gives you a cold.
Right.
It's not bad. It's just you gotta
just doing its
replicate. It's doing its thing.
It's replicating its thing.
Right.
Yep.
And the E. coli that sometimes gives us sickness is actually an important symbiotic relationship with us.
Right.
So I'm just saying.
How do we get to that next level of consciousness, though? Because really, evolution has really just taught us to replicate.
We need to transcend individuality. We need to get to the higher level. So, slime mold, neurospora, is generally 10,000 little amoebas on the grass, but under drought, somehow they go find each other. They all stream together, and they start specializing, and they make a pod, and they make a spore and germ cells inside and a stalk. And that spore can survive 0 Kelvin and absolute vacuum. Could be a space traveler, actually. And when there's warmth and moisture again, the spore cells, the seed cells, multiply and lyse open the pod, and they go out their own way as 10,000 little amoebas. What will it take to make humans, as individuals, see themselves as part of a larger whole, to transcend their individuality and be part of Gaia? And it will take a stressor, like it did for the slime molds. One such stressor might be encountering intelligence much greater than humans that would make us drop our little squabbles and say, wow, what can we learn from these guys?
Do you think that's happened before?
I don't know.
Something, it seems like happened at some point, maybe in the Cambrian era, that transformed humans.
Humans got the brain size that they are now long before civilization came along.
Right.
And we don't know what happened there.
Right.
And there are lots of speculation that, fungi had a role in that, or spores from outer space had a role in that.
This is what we were talking about.
And I think that speculation isn't good enough.
Yeah.
I think you need hard evidence.
Can't know. Yeah.
And I can't turn back the clock and go there.
Right.
But if there is, if consciousness is much bigger than we think it is, seeing the bigger picture of consciousness could radically accelerate a world shift, a shift in worldview,
right,
to taking the higher road. Instead of this selfishness and greed, how can I do something useful? How can we transcend our individuality, be part of something bigger? Now, I don't know how to make that happen, but
you're going to try.
I think we're not doing so good with the way we're going.
Yeah,
I'm worried. I'm worried about the state of humanity, and I don't know. I don't have the solution, but I think we need some help, and I think it's more along the lines of re-envisioning who we are.
Mm-hmm.
Each of us has sort of circles of identity. I'm the guy in this body, And I'm part of my family. I'm part of my town. I'm part of my country, my globe. I'm part of the cosmos, right? But the bigger we see ourselves, the more we fit into a global ecology. I don't think it's the survival of the fit in us, or the fittest, not the biggest, baddest, meanest. It's the survival of the fit in us, those that contribute more than they consume, those that make a difference in a good way. Steve Jobs kept talking about making a dent in the world, and I think he meant in a good way, not
right.
Like just, I don't know, there are things you could do that would make you well-known and famous that wouldn't be good for the world.
It never seemed like his motivation either. I mean, he called this the bicycle for the mind. He was really about...
Okay, so why he called it the bicycle for the mind. Scientific American did a study of efficiency of locomotion, and the condor whooped ass over the human. But they put in a ringer, which was human plus bicycle,
right.
which did better than the condor.
Right.
So he called it, actually at one point he wanted to rename the project Bicycle.
Really?
But that didn't stick.
Instead of Macintosh?
Yeah.
Bicycle?
No, we called it Mac, and nobody was going to change it. He wanted to change it to Bicycle because he didn't want it to have Jeff's name on it. Jeff named it one. And Jeff even named it the wrong kind of Macintosh. That wasn't an Apple. There was
he made MAC
MC and MAC
amplifier
right.
instead of the Apple.
So here's the funny part. In the Mac development team, we had a poster on the wall, a drawing of a wheelchair with a brain on it. And we said, wheelchairs for the mind.
Now I know why you
training
laughed.
Wheels for the mind.
Now I know why you laughed. Bill, we're very lucky that you're in this world, and I have a feeling you're not done yet. I'm looking forward to seeing what else. Would you come back again as you make progress in this journey?
I would be honored to.
Fill us in.
You're a really good interviewer. It's really always, I look forward to being interviewed by you.
I do too. I look forward to it too.
Some other interviews I kind of, I'm worried they're going to trip me up and make me say stuff that I don't really believe. And
right.
I think you have a way of putting me at ease, and you ask good questions that allow me to represent myself fairly.
You don't need much help. You're doing a good job. I like sitting at your feet and listening to the master.
I'm at your feet too.
The feet of the master. I don't know what more to say, except everybody needs to go buy photocard and use it, because we need to keep Bill gainfully employed.
Wait a minute. That's not true. I don't make money on photocard. I've been doing it for 10 years.
You lose money on it,
I'm tired of it. I'm
Are
actually,
you?
yeah.
You want to hand it off?
I would love to hand it off. I just can't because it doesn't make any money.
Nobody wants it.
Well, and also not enough cards are being sent. 400 a week.
Well, that's why I want people to do it.
There should be 10,000 a day. And I think maybe people don't want it. Not enough people want to send cards, printed cards.
Yeah.
So,
are you thinking about shutting it down?
Oh, I always think about it, but I don't, because the problem is I have too many people that do use it, that love it, and it would be really sad if I stopped. And so, I commissioned an Android version, or actually a cross-platform version that would run on web browsers, on Android.
You were talking about that last time you were here. What happened to that?
Yeah, and we worked on it for, I brought in an outside development company to do it, because I don't know anything about developing for cross-platform for Android and web and all that. It has to be all done in Java. And we worked on it for 1 3/4 years, and we got something that does work on those platforms, and it doesn't quite meet my standards of quality. And I think about, okay, if I'm getting 400 cards a week, and I'm spending a lot of time at it, this takes my time. And when I have to go on a trip, there's only one other person on the planet that knows how to process the cards, and she does it as a labor of love, as a gift to me. My friends Sean and Mary live in my house and take care of my dog and take care of the cards. But it's a big burden. It's a big responsibility. I take it very seriously, and I'm reticent to get in deeper.
Yeah.
I did try going to Hallmark and saying, I want you guys to distribute and maintain and support this thing. They're the right guys. They would do a good job of it, and they're not interested. They got their own little project they're working on, and So it wouldn't free me of doing the photocards, and so it wouldn't actually help. So when they come out with their product, maybe I can steer some people over to use it. But there are other card apps. I think one of the better. Well, none of them have custom stamps. None of them have custom stickers, and
we made. That's how we do our.
None
Christmas
of them are
cards.
as big as mine. Mine are a half a sheet of typing paper.
No, they're beautiful and they're laminated. That's how we do our Christmas card every year. And what we did, because in the past we used to have people sign, everybody in the office sign 400 Christmas cards, and now I just got everybody's signature and each person's a stamp, and I just arrange the stamps on the card. Yeah. It saved us a lot of time.
And you could use a mailing list and all that.
We love it. We love it.
But my mind is elsewhere now.
Yeah.
I do it because of obligation, not because of passion.
Well, it's time to stop then, maybe. Yeah.
Well, now there's too many people using it. I don't want to stop. But I'd really like to find a good way to hand it off where it would get fully supported.
Right.
And I price the cards for cost recovery. It's $1.50, including the 47-cent stamp, including the printing and the lamination, and those costs have all gone up.
Right.
And I don't want to charge a bunch more because then I would get even less cards being sent. So I'm looking for a way to hand it off that will support everybody that's using it, including myself. I send myself a lot of cards.
I can tell you brought a stack.
I have big bulletin boards that remind me what's going on good in my life.
Yeah.
So I'm one of the users, but I'm not actually the biggest user.
Who is?
A guy named Santa Bob lives in Las Vegas, and he's a professional Santa, but also he is a historian for the Salvation Army, and so he does a lot of cards that are really historical cards.
That's neat. So you feel an obligation. Santa Bob, thank you. Thank you for keeping photocard around. Now it's time to free Mr. Atkinson. How long do you want to live? Do you want to live forever?
No. I want to get out of the way. Let the younger ones in.
But you still have things to do.
I like it to make it to 100. I'm 66 now.
Seems fair.
Am I 66 or 67? I'm 66. I have to do a little subtraction in my head. I'd like to make it to 100, but if I only make it to 90, first of all, I already had a really good ride. I got no complaints. If I die in a car accident on the way home, and this is not a prediction, and I will keep my hands on the steering wheel and keep the ID on the road.
Yes.
You can't trust autopilot to do the whole job. But no, if I die shortly, I already had a really good run.
Yeah.
I got no complaints.
Yeah.
But I still have some ideas, and I feel like I still have something to contribute.
I think so.
But it's not in the area of computing. It's more in the area of the science of mind. And at this point, all I can do is read like crazy and maybe take a few forkfuls.
Bill Atkinson, thank you so much for your time. We appreciate it. Come back. We'll keep up.
I will.
Keep up to date.
I promise.
Got to see more of you. We do Triangulation every Friday, 3 p.m. Pacific. See why you want to tune in? 6 p.m. Eastern, 2200 UTC. If you can, watch live at twit.tv/live. If you do that, join the chat room at irc.twit.tv. And, of course, on-demand versions of everything we do are available on our website, twit.tv/TRI in this case. And that means you can go back and hear some of the amazing interviews we did with Bill a couple of years ago, and Jeff Hawkins when he talked about his book on intelligence and Numenta, and there's all sorts of great stuff in there. Check it out, twit.tv/TRI. Subscribe in your favorite podcatcher, and that way you won't miss an episode. Thanks for being here. We'll see you next time on Triangulation. Bye-bye.